Hi, Mr. Richards here, and today's algebra lesson is on scientific notation. We will learn how to express numbers in scientific notation and how to find products and quotients of numbers expressed in scientific notation. Now, our first examples deal with standard form to scientific notation. So our numbers will be written in standard form and we need to get them into scientific notation. So we'll use our key concept box here and we'll take it step by step to make sure we have good fundamentals of how to get these numbers into scientific notation. Well, the first step is to move the decimal point until it is to the right of the first non-zero digit. The result is a real number A. Okay, so let's rewrite this number here. 4,062,000,000,000 and a whole bunch of zeros that go with that. So let's move the decimal point, which is right here for right now. And let's count as we do this. We're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is going to become 4.062000000, and I think another 3 zeros there. All right, and we moved it 12 times. Now step 2 says, note the number of places n in the direction you moved the decimal point. Well, we moved it 12 places to the left. Okay, next. Oh, so by the way, that means n is going to equal 12. If the decimal point is moved left, write the number as a, which is this thing, times 10 to the n, which is this thing. And so we move to the left, so this is going to be a positive n, not a negative n. Okay, so step 3, rewrite this thing. Okay, this is going to be 4.06200000000 times 10 to the 12th. Step 4, remove the unnecessary zeros. What are unnecessary? Well, all of these. So this is just going to become 4.062 times 10 to the 12th. And that's our answer. Now, is it possible to combine these steps so you don't have to rewrite all of these zeros all of the time? Yes. Once you recognize, all right, I've moved this decimal point over 12 spots to the left, so it's going to be a positive 12, so times 10 to the 12th. And once you recognize that these are going to be the unnecessary zeros, can you combine these into 1 or 2 steps in order to just get down to step 4? Yeah, I'm okay with that. But if you're struggling with getting numbers from standard form to scientific notation, these 4 steps will get you there the right way every time. In our next example, we have 823 billionths. And we want to write this number in scientific notation. Well, we have our 4 steps. And when I talked about combining some of these steps, let's try that here. Let's rewrite this number as 0.000000823, or 823 billionths. Again, you might wonder, why do we use scientific notation? Well, it's to rewrite numbers like 823 billionths a little bit easier. Now, let's move this decimal point. We're going to go 1, 2, 3, 4, 5, 6, 7 spots. And we can rewrite this number as 8.23 times 10, and we moved this 7 spots, but we went 7 spots to the right, so this is going to be to the negative 7th. So when I talk about combining these 4 steps into 2 steps, well, we rewrote our number, we counted our decimal points as 7 spots to the right, and as it says, if you move your decimal point to the right, write the number to the negative exponent, and we did. We removed the unnecessary zeros in the process, and 8 and 23 hundredths times 10 to the negative 7th is our correct answer. Now what about scientific notation to standard form? Let's do this one step by step to make sure we understand the steps, and the next one we may be able to take the shortcuts. So step 1, in a times 10 to the n, note whether the n, the exponent, is greater than 0 or less than 0. Well, in this example, 6.49 times 10 to the 5th, that n is greater than 0. So the exponent is 5, so n equals 5. Step 2, if n is greater than 0, move the decimal point n places to the right. Well, in our number, 6.49, what we're going to need to do is to write a whole bunch of zeros here. How many? Well, 5's a good start. You can write 6, 7, 8. Doesn't really matter, because what we're going to do now is take this decimal point and move it as it says, n spots to the right, which is 5. 1, 2, 3, 4, 5. Decimal point's going to go right there now. It says insert zeros, decimal point, and commas as needed for place value. Well, let's rewrite the number. 6, 4, 9, 0, 0, 0. And the decimal point was there, which we may or may not need to write. And this is 649,000, which we need a comma between the thousands and the hundreds. And that's our answer, 649,000. Now we have 1.8 times 10 to the negative third. Well, it's still good to note here that we have a negative 3. So when we go to rewrite this number, 1.8, since n is less than 0, we're going to move the decimal point that many spaces to the left, So as we throw in our zeros here, and again, as many as you think you need, we're going to move this decimal point 1, 2, 3 spots to the left. So we have 0.0018, or 18, 10, hundreds, thousands, 10,000s, 18 10,000s, and that's our answer. So again, it is possible to do these without the step-by-steps, but the step-by-steps do give us the fundamentals of what we need. Now we get to multiply with scientific notation. Our directions state evaluate each product, express the results in both scientific notation and standard form. What we're going to do here, we have 5 times 10 to the negative 6 times 2.3 times 10 to the 12. What we're going to do is regroup these. This is all multiplication. So we can regroup these using our numbers here as 5 times 2.3, and then we can multiply that by the 10 to the negative 6th times 10 to the 12th. Well, when we do 5 times 2.3, we end up with 11.5, and then times 10 to the, well, here we have a power times a power, and the rule there is we're going to add the exponents. So negative 6 plus 12 is 6. And so we have 11 and 5/10 times 10 to the 6th. Now, technically this is not in scientific notation. Scientific notation, we're just going to have one number to the left of the decimal point, just the 1. So this is going to be rewritten as 1. This goes back once to the left, 0.15 times 10 to the 7th. As we move our decimal point to the left here, this number is going from 11 down to 1. And the best way I can explain this is, since this is going from 11 to 1, that got smaller by a power of 10. So we need to get our 10 to the 6th bigger by a power of 10 to match it. 10 to the 7th. Again, think about it. This 11.5 went to 1.15. This got smaller by 1 spot. So then the opposite of that, this needs to get bigger by 1 spot in order to match. So that's the answer in scientific notation. Now, we also need to get this into standard form. And we are going to have our 1.15. I'll put on a bunch of zeros here. And since this 7 is a positive number, we're going to move our decimal point to the right. 1, 2, 3, 4, 5, 6, 7. It's going to go right there. So 1, 1, 5, 0, 0, 0, 0, 0, comma there, looks like 11,500,000. So our solution, 1.15 times 10 to the 7th and 11,500,000. Same number, one in scientific notation, the other in standard form. What about quotients? Express the result in both scientific notation and standard form. Well, for quotients, we're going to follow the same logic here. We're going to look first at the 4.5, or 4.5, 4 5/10, and divide it by 1 5/10. And that's going to be multiplied by this part here. 10 to the 8th divided by 10 to the 10th. Well, when you take 4.5 and you divide it by 1 5/10, your result is 3 times 10 to the, well, power divided by a power you're going to subtract. 8 minus 10 is negative 2. So we have 3 times 10 to the negative 2. And that's just fine for scientific notation. 3 times 10 to the negative 2. Now, to get this into standard form, our decimal point's there. We have a negative number, so we have to, or a negative exponent, so we're going to be moving our decimal point to the left 2 times. So this answer is 0.03, or 3 hundredths. So our answers are 3 times 10 to the negative second and 3 hundredths. Today's math video is not sleepy, it's not tired, but it is brought to you by one of those types of words. Did you know there's only one English word that ends in the letters MT? Well, we'll start there and we'll start filling it in and see if you can guess as we go. Do you know what it is yet? Well, if you would have guessed dreamt, you would be right. Dreamt is the only English word that ends in the letters MT. Last year, AJ's state registered over 400,000 watercraft. Boat sales in his state generated more than $15.4 million in state sales taxes that same year. Express the number of watercraft registered and the state sales tax generated from boat sales last year in AJ's state in standard notation. Well, if we look at the watercraft registered, that was 400,000, which we can just write as standard notation, 400,000. As for the state sales tax, taking the $15.4 million, well, we can write our dollar sign. 15.4 million is 15 million, and then 400,000. And getting these numbers into scientific notation, let's deal with the watercraft first. The 400,000, right now our decimal point's there. And we're going to move it over once, twice, 3, 4, 5 times. So this is going to become 4 times 10 to the 5th. Our state sales tax. Well, 15,400,000. Right now our decimal point is right here. And we're going to move the decimal place over once, twice, 3, 4, 5, 6, 7 times. So this is going to be 1.54, don't need the zeros, times 10 to the 7th. So we have standard and scientific. How many watercraft have been registered in AJ's state if 12 times the number registered last year have been registered in all? Write your answer in scientific notation and standard form. Now in this case, I think it's easier to take our number in standard notation, which would have been our 400,000, and multiplying that by 12. Because that will get us 4,800,000. And of course that now already is in standard notation, which is part of the answer. And now to get this number into scientific notation, we're going to move this decimal place over 1, 2, 3, 4, 5, 6 times. So it's going to equal 4.8 times 10 to the 6th. So sometimes you can compute in scientific notation, sometimes you can just use your number that was in standard notation and compute with that. That is it for this lesson. Good luck.